Hey guys, so this is the week 3 lesson of the YSP second grade curriculum for this spring. This is the first lesson where we've talked about materials the past 2 weeks. Now we're going to start talking about matter more specifically. So it's more chemistry related, I guess. But keep in mind that matter, the word, is like a completely new concept to them. And it's kind of hard to explain what matter is because it's just like everything. So keep that in mind that might take a little bit for them to grasp, but giving examples is a really good way to do it. So the premise of this lesson is each kid gets a chocolate bar, and we're taking the chocolate bar and we're melting it with a heat pack and then freezing it with a cold pack. But you don't say that you're melting or freezing it. That's for them to figure out what's going to happen. But just that's what happens, hopefully. Um, so how it works is first thing you should do is give them the heat pack and ask them to kind of shake it around and then tell them, please put this on the desk in front of you. If I see anyone messing with it, then I'm just going to bring it up to the front of the classroom, which is what I ended up doing for 2 out of 3 of my classes, anyways. Um, and so once they've done that, I start introducing the concept of matter. And I define it as matter being anything that takes up space. And I have them give examples of anything that's taking up space in the classroom right now. And usually they think of the solid things because that's what they see. Someone has a water bottle on their desk. I can ask, is the water taking up space inside the water bottle? And they usually can say yes. Air is usually the hardest, but how I like to describe it is inside a balloon. When you blow up a balloon, there's no solid or liquid in there, there's a gas, so that's air. Um, and that's also something that's taking up space inside of the balloon. So the way I first describe it is I say, what's a molecule? And I explain it's the smallest unit of matter. It's like the smallest tiny piece that matter can be. And then I show them this picture, which helps them understand it a little bit more. So I say in solids, the molecules are all super close together. In liquids, they're spread out a little more. And in gases, they're spread out even more. And then I explain that solids have their own shape and liquids kind of take the shape of the container. So if I took it out of a water bottle and poured it into a cup, it would take the shape of the cup. They usually get that. And then I explained that gases will just spread out as far as they can go until they hit something that they can't get through, like a wall. And that usually takes a lot of examples for them to understand, but generally they seem to get it too. Um, then I kind of explain if they were a molecule, if they were all super close together and not moving, I asked them, do you think you'd be colder or hotter if you were running around outside really, really fast and not staying still? And generally, they can explain that they would be much hotter if they were running around everywhere. And then they kind of can deduce that gases are hotter than liquids, which are hotter than solids. But that takes a little bit more reinforcing, but that's the premise of this whole lesson. So that's perfect. So the question I have for them is what happens if you heat and then cool chocolate? Notice that I did not say what happens if you melt and then freeze chocolate because that's for them to come up with. And then I have them predict what will happen to the chocolate. And this one I kind of left more open-ended because I think that they can fill it in. And they proved me right, they could. So I have them all take their chocolate and their heat pack, usually one heat pack for 2 people, and put the chocolate under the heat pack. And I usually do this before they even write down their question or their prediction so that it has enough time to melt. And then after they're done with that, I ask them, done writing their questions and predictions, that is, I ask them to feel their chocolate and make observations out loud about what it feels like. So normally they'll say squishy or warm or soft. And then I will go around and distribute the ice packs and then tell them to put them under the ice packs now. And then ask them to predict what they think is going to happen to it. And then after they are frozen again, I'll ask them to give me observations out loud again. What does it feel like? And they usually say it's hard, they can break it, things like that. After all of that, I ask them to open it, which they're really happy about, and then ask them to eat it. And they're always really surprised, like, it doesn't taste different. It still tastes good. And then we go into the explanation that it's still made of the same matter. So then I go back to this and I said all that was happening is that the matter, the molecules in the matter were moving farther apart and then coming back close together. So is it still the same chocolate? Is it still made of the same thing? They usually can say yes. So we all know that that's a physical change and not a chemical change, but introducing physical and chemical changes might be a lot for this lesson. I only did it in one of my classes that was the most advanced, but if you think your kids can get it, it'd be a good idea to explain that what just happened was a physical change because the matter did not change what it was made of. It did not make something new. It was still chocolate. It still tasted the same, even if it looked a little bit different. And if you can explain this now, that will definitely help for the week 4 lesson, which talks about chemical reactions. If not, that's okay too. You don't want to overwhelm them with too much content. And then here's just a picture of a girl really enjoying eating her chocolate bar after she has melted it and refrozen it. And then I just have them write their conclusion saying what happened to the chocolate. And I let them be a little more open-ended and they can write that it looked different or it still tasted the same or whatever they want, just to show that they understand that it changed how it looked based on the temperature it was in, but it didn't change what it was made of.